Antenna arrays. First of all, what is arrays? Array means what? Group of antenna. Array means what? Group of antenna spaced with some distance. Okay, separated by some distance. Group of antenna separated with some distance. Okay, so what is array? Array means group of antenna, separated group of antenna separated with some distance, separated with some distance. Okay, some fixed distance. Say for example, if I am having one antenna like this, say for example I am having one antenna. Okay, this is one antenna, lambda by 2 dipole, and I am having another antenna, like this. So this is called antenna arrays. Okay, so I'll write like this. Others, please mute the mic. Okay, suppose if I'm having one antenna like this and another antenna like this. Now the spacing between the antenna is d. Okay, the spacing between the antenna is d. And again, if you calculate the spacing between adjacent successive antennas, that is also same d. Okay, so when you have a group of antennas spaced with some distance, that is called as antenna arrays. Then the next question is why we are going for antenna arrays? Why we are going for antenna arrays? What is the need of antenna arrays? The first need is to increase the gain. Okay, you are at some place, when you are using some antenna, say the transmitter is using some antenna, then you are not getting the sufficient power at the receiver. Okay, then what has to do? Either you have to increase the transmitter power or the transmitter gain has to be increased. So the antenna array increases the gain of the antenna. So the antenna array increases the gain of the antenna. So to increase the gain of the antenna. So what is the need of array? To increase gain of antenna. Gain of antenna, because it is okay, because when you have one antenna you are getting some power. When you have many antenna, okay, placed near to each other, then there will be definitely you will receive power due to all antennas. Then and again you have to feed these antennas in such a manner their voltages and currents and as well as phases are same, then you'll get more power. Okay, when you have, see, if you are getting some power with one antenna, if you are having n antenna, then you will get n times of power, simply that n times of electric field, something like that. So simply need of antenna is to increase the gain of the antenna. So once if you increase the gain of the antenna, then definitely the received power will increase. That's the idea. Then what is the another need of antenna? To radiate in a particular direction. Okay, this is hidden actually, but you should know this. To radiate in particular direction, to radiate in particular direction. Okay, to radiate in particular direction without altering the physical position. That is the main idea. Okay, because once if you change the physical position, you can radiate in any direction you want, because once if you change the orientation of the antenna, then definitely the direction in which the radiation goes also will vary. But without changing the orientation of the antenna, then if you want to radiate in a particular direction, in a direction of your interest, then that is possible with the help of antenna array. So to radiate in a particular direction without changing physical structure, physical orientation. Okay, so one by one we'll see. So for example, say if I am having one antenna like this, you know very much clearly that will radiate in this direction. Suppose lambda by 2 dipole antenna, the maximum radiation will be in this direction. If I have an antenna like this, I can radiate in this direction. If I have an antenna like this, I can radiate in this direction. But what I am doing now the direction of interest is changing, and also now I am changing the orientation of the antenna. Physically I am changing the antenna. So what will happen if the user is here, your antenna has to be here. If the user goes there, then your antenna structure has to be changed. Then practically that is not possible. When the user is changing its position, then again the orientation of the antenna has to be changed. Then practically that is difficult. That's not possible. So then we'll try to, so what is mainly important? So when I have an antenna like this, my radiation is in this manner. When the person goes here, my radiation has to be in this direction. When the person comes here, exactly my radiation has to be in this direction. So without changing the orientation of the antenna, somehow I will try to change the direction of radiation pattern then I achieved my purpose. That means what? Without changing the physical structure, my radiation pattern direction is changing. Then I can cover the particular user wherever he goes. That's the idea of the antenna arrays. Then one more thing is very, very clear, because if I have an antenna here, if I receive the electric field due to antenna 1, then definitely if I have another antenna, say this is antenna 1, this is antenna 2, then definitely the electric field here is the sum of E1 and E2. Definitely I will get 2 times the electric field, then my power also will increase. But I have to place the antenna close to each other, then what will happen then? And again, you have to make sure that the current that you are feeding here, see, if it has to be true, the current that you are feeding here, the phase that you are using here, say I1 theta 1, is exactly same. This is also I1 theta 1. The current value as well as the phase has to be same. Then only this is E1 plus E2. Suppose, for example, if you are using I1 theta 1 here, okay, I1 theta 1, if you use I2 some other theta 2 here, then you do not know what will actually happen. See, this may be E plus E2 or E minus E2, or with, and again, you know what is the angle. Depending on that, you will have some coefficient also, K1, K2. You do not know finally which value you will get. So if you want to constructive addition, then here the current and phase has to be same, because you know, or otherwise, say for example, what will happen? See, in simply, if you are having I1 0 degree and same I1 you are having here with 180 degree, that means what? If the current flows upwards here it flows downwards. So if it creates electric field in this manner, it will create opposite electric field. Then what is the electric field here? Electric field may become 0. So that's why I'm telling, whenever you have antenna arrays, you have to be very careful. What is the current value? What is the angle? Okay, phase angle of the excitation and everything. You have to be very careful. Okay, so the antenna array is used to increase the gain of the antenna. In such a way, you have to supply your current and phase. And again, question may arise, say if I am an antenna like this, why can't I put my one more antenna like here? Because once if you bring one more antenna here, you will not get any gain here, because you are simply increasing the length of the antenna. Just you are simply increasing the length of the antenna. Then again, you will have some impact here, but you will not have increased gain. You will have some other impact, because it's like increasing the length of the antenna. Okay, once if we increase the length of the antenna, then you should know what will happen to your power, what will happen to bandwidth and all. That's a different topic. But antenna arrays, we always put the antenna like this. Okay, so this is antenna arrays, because once if I put antenna like this, say I am putting antennas like this. So now, and again, you connect all these antennas. This is called array axis. Antenna array axis, very important. Antenna array axis. Okay, I am having antenna like this. This is the antenna array axis. Okay, the antenna array axis will be in this direction, because we'll always discuss the radiation pattern. We'll always discuss with respect to antenna array axis. Okay, that's the idea. Okay, next, say for example, now I'll put some 3 to 4 antennas. Okay, I'm having one antenna. Please imagine that the conductor is exactly going inside the screen. You are seeing only like a front view. The conductor is actually going inside the screen. Okay, the same diagram only I'm putting here, but the conductor is really going inside. So this is another antenna. Or otherwise, you can assume this as here isotropic antenna also. That's also okay. Okay, you can assume it as isotropic antenna, or otherwise you can assume it as assume like a conductor is really going inside the screen. Both are okay. So for a moment being, you assume it as a isotropic antenna. So I am having 4 isotropic antenna. Okay, the current, okay, current here is I1, I2, I3, I4. Okay, here it is alpha 1, alpha 2, alpha 3, alpha 4. This alpha 1, alpha 2, alpha 3, alpha 4 and all phase, okay, phase of the signal that you are exciting. Okay, what is the phase difference? This is the current, this is the phase. Now, by varying the current and phase, you can control all properties of antenna arrays. Because why we are designing antenna arrays? To increase the gain, to get the gain in a particular direction. Only 2A. Okay, the objective of antenna array is only 2. You can radiate in any direction you want by controlling this parameter, and also you can get any gain you want by controlling this parameter. Okay, so this parameter, the current and phase excitation of the antenna, is controlling the antenna array properties. Okay, see, finally the current and phase of excitation controls the antenna array properties. That you have to be very clear, because you are having more than one antenna. Then what is the current of all the antenna excitation current? What is the excitation angle of all antennas? So current and phase of excitation of antenna decides antenna array properties. Antenna array properties. That means what? Finally, my maximum radiation may be anywhere. My maximum, see, if I am connecting all these dots, if this is like antenna, what? Antenna array axis. If I connect, this is array axis. Finally, my maximum radiation can be here, something perpendicular to the antenna array axis, or it may be here, something along the array axis. Anything may happen, or something it may be in between. Okay, so I do not know in which direction is maximum radiation is going to be. That all depends on I1, I2, I3, I4, and alpha 1, alpha 2, alpha 3, alpha 4. And one more thing, at any point of time, say if you are on the space, okay, somewhere, I'm standing here, this is my observation point. Definitely my field here is, electric field here is due to all this one. Okay, my electric field will come in this direction and in this direction and in this direction. And you take this as a theta. But once if it is theta, you cannot take this also as a theta. Definitely the angle will be really different. But if you choose this point very, very far away, okay, at an infinite distance, if you choose this point at very, very far away, then angle of all this is same. This is also theta, then this is also theta, like this. That means what? Once if you choose P very, very long, this distance, and all this distance will be same. Please imagine, once if you choose the point P at infinite distance, all this length will be same. Okay, approximately same. So, and again, even if it is same, that's okay. But what is happening? Say, for example, if I consider only two element array, okay, I take 2 element array. Now, here, somewhere here, yes, sir. Suppose if this is theta, this is the distance between the radiators, okay, antennas. This is the distance between the radiators. Yes, tell me what will be the path difference if this is theta, this is d cos, yes, sir, this is what? D sin theta, and this one is d cos theta. So that means what? The distance is, suppose if it is x, this is also x, then this distance is greater than this one by what amount? D cos theta. That means what? Suppose if you are exciting the antennas, say this is of current I, this is also with the current I, and you are providing some phase, say for example, if you are providing phase difference for second antenna, first antenna without a phase difference, 0 phase difference, and as compared to the first antenna, the phase of the second antenna is I, okay, I alpha, that's okay. Now, somebody tell me which wave will reach the receiver very quickly. You are exciting both the antenna at the same time. Among these, which wave, okay, the wave from this antenna 1 will reach the receiver very quickly, or from 2 will reach the receiver very quickly? Anybody? ரெண்டு ஆண்டனாவுமே ஒரே நேரத்தில் எக்ஸைட் பண்றீங்க. Which wave will reach the receiver very quickly? Anybody? No idea. எது சார் குயிக்கா ரீச் பண்ணா? புரியலையா? இங்க இருந்து ஒரு வேவ் ஸ்டார்ட் ஆகுது சார், இங்க இருந்து ஒரு வேவ் ஸ்டார்ட் ஆகுது அட் ஏ டைம்ல. இது இவ்வளவு டிஸ்டன்ஸ் டிராவல் பண்ணணும், இதுதான் டிராவல் பண்ணணும். இதுக்கு டிஸ்டன்ஸ் கம்மி, இதுக்கு டிஸ்டன்ஸ். Second one will reach the receiver very quickly. Second one will reach the receiver very quickly. Then as per the wave point of view, if some wave is reaching a particular point very quickly, means that wave is having positive phase. The phase of the wave is positive. This is going slowly. This wave lags. Okay, this is reaching the receiver very fastly. This is lagging. Okay, so how much amount this is lagging or how much amount this is leading? Already this phase is lead by alpha, and also it is taking less time so that it reaches the receiver very quickly. By what amount it will reach the receiver very quickly? By what phase? Already I told you, once if you know the theta, you can calculate t, no problem. So by what time? By by what phase it reaches very quickly? What is the phase lead of this wave? The phase lead of the wave depends on two factors: how much quickly it has reached the receiver as compared to this one, and what is the excitation phase here. Because I come to the conclusion that definitely the wave 2 will have the phase lead as compared to wave 1, because it is reaching the receiver very quickly, and is also already it is having phase lead. So finally the total phase lead of the wave 2 is defined by psi, that is d cos theta is there. You know one thing, when you want to travel a distance of lambda, you will complete 2 pi phase. Okay, then if you travel d cos theta, how much? Okay, d cos theta, how much distance? What is the angle produced by you? Any idea is there? Otherwise, I'll tell you another way. You take transmission line, sir. If you have a transmission line, if you travel a length, what is the phase produced by you? Beta L. Similarly, if you travel the length d cos theta, what is the phase produced by you? Beta d cos theta. That means this wave will advance as compared to this wave by the factor of beta d cos theta as well as alpha, because already phase lead is there. So finally the wave 2 will lead the wave 1 by the amount of beta d cos theta and alpha. Sometime alpha may be 0 also. Both the excitation phase can be 0 also, but again for analysis purpose I can take later anything, because that's why I'm taking alpha. Okay, so that is the psi is equal to beta d cos theta. Okay, it will give you some direction, because psi you have when psi is equal to 0, that is the condition for maximum radiation. Very important. Why this is true, I will tell you later. Whenever psi is equal to 0, then that is the condition for maximum radiation. Okay, it will indirectly, it will give you the direction of maximum radiation. Once if we make psi is equal to 0, indirectly it will give you the direction of maximum radiation. So what is the condition to find out the maximum direction of radiation? Psi is equal to 0. Very important. That is the beginning point for antenna arrays. Okay, always let it be 2-point array or n-point array, whatever it may be, psi is equal to 0 is the condition for maximum radiation. Very important condition. Psi is equal to 0 is the condition for maximum radiation. Now from this I will proceed. Okay, so now my psi is equal to